यश आवाज येतोय का?
हो येतोय सर.
व्यवस्थित येतोय ना?
हो हो.
स्क्रीन दिसतीये का? Anyone tell me? Write your name and seat number in the chat box. Also write screen is visible or not. Or unmute yourself and tell me. सार्थक जोशी, स्क्रीन दिसती व्यवस्थित? आवाज येतोय माझा? ओके. अजून 1 मिनिट वाट बघू आणि मग सुरू करू आपण. बाकीचे हळूहळू जॉईन होतोपर्यंत आपण सुरू करू. In the last week we discussed about the concept of hydrolysis and hydrolysis of different types of salts. There are 4 types of salts. Once again I will show the 4 type of salts. See, these are the 4 types of salts. So first one is a salt derived from strong acid and strong base. Both acid and base both are strong. Some examples are given here: NaCl, Na2SO4, NaNO3, KCl, KNO3. These salts are formed by strong acid and strong base. Then second type of salt is salt derived from acid is strong but the base is weak base. So the examples are also given here: copper sulfate, NH4Cl. We also discussed this hydrolysis of copper sulfate. So these are the salt of strong acids and weak bases. Then the third type is base is strong but the acid is weak. So these are the salts derived from weak acids and strong bases, in which the acid is weak acid. The examples are CH3CONA, KCN, and Na2CO3. And then last fourth type is both are weak. Weak acid is also weak and base is also weak. These are the examples of ammonium acetate and ammonium cyanide. So we discussed about this hydrolysis. Any one hydrolysis can be asked for the board examination, remember. Or many times no question it is asked on it. But example at least examples you should know, because the chapter is very small and the weightage is I think 5 marks weightage for this chapter. Once again, I want to check the weightage. Six marks weightage is there. So out of these 6 marks, one numerical will be there 100%. So remember, if a numerical is asked, no any larger question will be asked on this hydrolysis. So the numerical may be asked on 2 marks or 3 marks. Now we will discuss the buffer solutions. This is newly added concept in this chapter, buffer. Yes, anyone knows about the buffer solution? Anyone can tell me? Wait, I will. Yes, mute yourself and tell me. Unmute yourself and tell me. Anyone? Do you know this word buffer? आवाज येतोय का? अनम्यूट अनम्यूट होत नाही का? Anyone? कोण कोण लेक्चरला आहे मला चेक करू दे जरा आज. संस्कृती भोसले. संस्कृती भोसले, unmute yourself and tell me, do you know about the buffer solution? You heard this word, buffer? Yes? आवाज येत नाही का? आवाज येतोय का? Anyone?
sir.
So anyone can tell me what is mean by buffer? No one? Yes, the screen is visible. Screen is visible. Anyone tell me?
Yes, sir.
Okay. So buffer, it is a solution. So this solution is very important. When a small amount of acid or when a small amount of base is added, its pH does not change. It is called as buffer solution. So buffer solution means a solution which resists the pH, drastic change in pH, when a small amount of strong acid or strong base or water is added to it. Means the pH is not changed. So why the pH is not changed, we will see the buffer action also, and what are the types of buffer. There are mainly the two types of buffer solution. One is acidic buffer solution. It is used to maintain acidic pH. And another type of buffer solution is basic buffer solution. Remember, another type of these are the two types, acidic buffer and the second one is basic buffer. So acidic buffer, the use is it is used to maintain the acidic pH. And what is the role of basic buffer? It is used to maintain the alkaline pH or basic pH. So acidic buffer solution, this can be asked for the examination part of you. Define acidic buffer solution. So always the buffer solution, it is prepared with acidic buffer solution, it is prepared with weak acid, and it salts with strong base. And opposite to this, the basic buffer, which is prepared with weak base and it salts with strong acid. This is called as basic buffer. We will see in this next slide. So first we will discuss this acidic buffer solution. Acidic buffer, now you understand, it is prepared with weak acid and it salts with strong base. So the example is given here. Solution containing weak acid, acetic acid, you know, this is a weak acid, and its salt, it is a sodium acetate, it is a salt with a strong base. So this is an example of acidic buffer solution. For the examination point of view, they can ask, write one example of acidic buffer solution. So we can write this example, the solution of acetic acid and sodium acetate, because it is a salt of weak acid with strong base. Here NaOH is the strong base and acetic acid is a weak acid. So this salt is prepared. Then pH is given by, pH of acidic buffer is given by this equation. pH is equal to pKa plus log to the base 10 molar concentration of salt and molar concentration of acid. This is equation number 3.23. The same equation we can write for the basic buffer solution also. Where pKa, you know about this pKa value, pK is equal to minus log to the base 10 Ka, where the K is dissociation constant of the acid and Kb will be the dissociation constant of base. So remember this equation, equation number 3.23. The same equation we can write for the basic buffer solution. Before proceeding, you must know what is meant by basic buffer solution. See, this is a basic buffer solution. So the basic buffer solution, we will discuss the definition first. A solution containing weak base, see, weak base and it salts with strong acid. This is called as basic buffer solution. So we will discuss first example. We will consider the weak base. Suppose NH4OH, it is a weak base and it salts with strong acid is NH4Cl. Here HCl can be used as a strong acid. So NH4, the mixture of NH4Cl and NH4OH, this mixture is called as basic buffer solution. So the pOH of the basic buffer solution is given. It is same as pH. So pOH is equal to pKb plus log to the base 10 molar concentration of salt divided by molar concentration of base. Equation number 3.25. So these two equations, equation number 3.23 and equation number 3.25, these are called as Henderson's Hasselbalch equation. Remember this name, Henderson Hasselbalch equation. These are the two scientists who given this expressions. That's why the name is given Henderson Hasselbalch equation. Now we will discuss how this buffer action will take place if the small quantity of acid is added or if the small quantity of base is added. Why the pH of the solution doesn't change. So we will take one example, buffer action. It is called as buffer action. So for this buffer action, let us consider sodium acetate and acetic acid buffer. So my question is to all the students, is this is a acidic buffer or is this is a basic buffer? Tell me, and why? Yes, anyone can unmute and tell me this is a mixture of acidic buffer or this is a mixture of a basic buffer, and why? Anyone? Hitesh, tell me 157. Hitesh Sutar, unmute yourself.
Yes, sir.
It is a acidic buffer or basic buffer, and why? Sodium acetate and acetic acid. Just we discussed in the previous slide what is meant by acidic buffer and what is meant by basic buffer. So tell me acetic acid and the sodium acetate. This is a acidic buffer or basic
Ma'am,
buffer?
acetic buffer.
Why?
Uh,
Yes, I
sir,
will help.
because uh, sir, because it contains the
Weak acid
weak acid and its salt
with
with
strong base.
strong acid.
Strong base.
Hmm.
Very good. So it is very easy to identify whether it is acidic buffer or basic buffer. We have to check first weak acid or weak base is there. So in this example, acetic acid is a weak base, and this sodium acetate, this is a salt with, this is a weak acid, and this is a salt with strong base, remember. So this mixture is taken. This is a mixture of acidic buffer in which sodium acetate, see, sodium acetate is a strong electrolyte because it is a mixture with, it is prepared with, it is a salt of weak acid with strong base. So it is a strong electrolyte. So it will be dissociate completely in water. So its dissociation is given by, so it is a dissociation of sodium acetate. Aqueous means it is dissolved in water, so it will produce the ions CH3CO minus aqueous and Na plus aqueous. So these ions are prepared by sodium acetate. On the other hand, weak acid is also there. Weak acid is acetic acid. So acetic acid is a weak acid. It will be partially dissociated, or the concentration of undissociated acetic acid will be high because it is a partially dissociated. It is a weak acid. So how the pH remains same, I will discuss. If a strong acid is added, means we are adding the percentage of H plus. So if a strong acid is added to the solution, means we are adding here, we are adding H plus ions. So the added H plus ions will be consumed by the conjugate base